second. Alright, so we're going to start with this one. It's still the direction of solve the right triangle, like we did on the first example that we did on Tuesday. But I want to do this one because, like I said, the triangles we've worked with thus far, I've given you a side and an angle. This one I've just given you two sides, but we can still solve for the three missing pieces. Right now we just don't know one side and two angles. And this is where we're going to incorporate some of our inverse trig stuff. Because remember, if you have two sides, you can use inverses to help you find an angle. So that's one thing we're going to work with. And then we're also going to touch on a little bit of angle of elevation and depression after we solve this triangle. Okay, so the three things we don't know are this side G, because it's opposite the angle G. We don't know angle F or angle H, okay? It really doesn't matter what you find first. What do you want to find first, the side or an angle?
The side.
The side, okay? If I know two sides of a triangle, how can I find the third side? Pythagorean theorem, yeah. So, to find my first missing piece, which is G, okay, what side is G? Hypotenuse, yep. So, since I know that that's the one I'm missing, that means that needs to be our C value. So my 9 and 5 are going to go in for my A and B. So I have 9 squared plus 5 squared equals C squared. Okay, I haven't labeled the other two sides yet because it depends on what angle we're talking about. And we haven't identified which angle we're going to find first. So let's finish all the way out for the side. So we have 81 plus 25 equals C squared. What's 81 plus 25? 106. And then we have to take the square roots. And again, this direction is to round. So I know 106 doesn't have a nice square root, but since I'm asking you to round and not leave it as an exact value, we're going to take the square root of 106, which is 10.29, which is 10.3. Alright, so now I know all three sides of that triangle. So I only know one angle right now. I know the right angle is 90 degrees. So I don't know either angle F or angle H. So we can still use SOHCAHTOA to help us out. But instead of using regular sine, cosine, and tangent, if we're trying to find an angle, we'll have to use inverse. So it kind of depends on which angle you want to find first to label what 5 and 9 are compared to it. So like I said, I labeled the hypotenuse because the hypotenuse won't change, but which angle I find first will determine what 5 and 9 are to it. So do you want to find angle F first or angle H first? F, okay? So I'm going to circle F, okay? So I'm labeling the rest of the sides based off of F because that's the angle we've decided to find first. So then, what is 5 compared to angle F? Opposite. And what is 9? Adjacent. Okay. So we have the unique thing. We can actually use any one of the trig functions because we know all three sides. Okay. So if you want to use sine, we can use 5 and 10.3. If you want to use cosine, we can use 9 and 10.3. If we want to use tangent, we can use 5 and 9. Okay. So that's the nice thing about having all three sides. Once you pick the angle, you actually can pick whatever one you want to use to find that particular angle. Okay? So what I typically use, and I know it's nice that we have the hypotenuse now, but we did have to round that. So to me, that's not quite as exact as the ones that were given to me. So I tend to gravitate towards using those two values because they're nice whole numbers already. So I'm going to use opposite and adjacent. So that means I'm going to use tangent to find angle F. Does that make sense? So I usually use a theta, but since I'm talking about angle F, I'll go ahead and use that letter. So angle F, I'm going to use the opposite and adjacent to find it. So I'm going to use tangent, but since I'm finding an angle, I don't just use regular tangent. What do I use? Inverse. Yep, so I'm going to use tangent inverse of the opposite and adjacent side, so 5 over 9. So in my calculator, I'm just going to do tangent inverse of 5 divided by 9. And so I got 29.05, so I'm just going to say 29 degrees. Everyone good with how I got that?
When it comes to a 5, wouldn't you rather have us round up?
Yeah. So you could have done 29.1. So a lot of times with degrees, I just err on just rounding to the nearest whole number. So that's what I end up doing with degrees. So we now know that this is 29 degrees. Do we have to use SOHCAHTOA again to find the third angle? No, because now I know two other angles, so I can just use a little bit of subtraction. So angle H is going to be 61 degrees. Because all three of those have to add up to 180. Now, if you use if you end up using the hypotenuse instead of the adjacent or opposite sides, your rounding might just be a little bit different, but as long as you're close, you're fine. So, any questions about solving a right triangle, or you just have two sides to start with? Okay. So real quickly, we're going to talk about angle of elevation and depression. Essentially, we've actually already kind of worked with it. One of those problems, my cross-country problem, was kind of an angle of elevation and depression question. So basically, it's formed from a horizontal object, either up or down from that object. So angle of elevation, and that's typically the angle we work with, is from usually your line of sight. And then if you have to look up at something, that is your angle of elevation. And then if you have an angle of depression, again, that's from your line of sight, and you have to look down at an object. So that's really the difference between the two of them. So angle of elevation, you're usually looking up at an object. Angle of depression, you're looking down at an object. Okay? Now, I like this picture, but if you really look at it, the scaling is way weird. Okay? Because this guy is the same height as that tree. So it's not really drawn to scale, but, and then.
That tree way off in the distance. Okay.
Right, exactly. So the sky is just really, really close to the camera, and the tree is just really, really far away. But
It's a bonsai tree.
yeah. But I do like the picture. But ultimately, again, then what happens to get our right triangle? You just take from the object straight down. That'll give you your right angle, and so that's our angle of elevation. Or from this one, straight down to the ground. Right there's our angle, right angle, so we have our angle of depression. You actually look at the two different ones, the angle of elevation and the angle of depression. They're actually the same triangle. It's just the angle of depression triangle is flipped upside down. Okay? So these two angles are actually the same each time. So what I always end up using is this angle down here at the bottom. So that, because we had that from geometry, the alternate interior things. So this actually are the same angle. It's just typically when we think about angle of depression, it's looking down at an object. We still just draw the right triangle upside down. And the angle of elevation is kind of the right side up triangle. So actually it's working with the same angle each time. So I usually make it easy on myself when I'm drawing out my triangles and just label this angle each time, because no matter if it's an angle of depression or angle of elevation, instead of just drawing an upside down right triangle, I just draw a regular triangle and label this angle each time. Okay, because it's the same angle. Like I said, angle of depression is just that triangle flipped upside down. So let's look at a couple of problems. So here we have a skiing problem. We're looking at chairlift. At a ski resort, it rises at an angle of elevation of 20.75 degrees while traveling up the side of a mountain and attains a vertical height of 1,200 feet when it reaches the top. How far does the chairlift travel? Now, if you want to, you can try to draw a mountain, try to draw a little ski lift, or you can draw a triangle. So like I said, if you wanted to, you can try to draw, like, here's our mountain. then here's our little ski lift. Keep it going up the mountain. Okay, that's about as good as I can do. So the chairlift, its angle of elevation is 20.75. Like I said, where we get angle of elevation depression is a horizontal distance rotating up towards an object. So the angle that I have is this one down here at 20.75 degrees. Okay. While traveling up the side of the mountain, it attains a vertical height of 1,200 feet. Where's my 1,200 feet going to go if it's a vertical height?
Opposite.
Yep, opposite side. Yep. So, like I said, Tuesday, if you're talking about a vertical height, it's this side of our triangle. So, for my 1,200 is going to go. Some horizontal distance is here, and then some sort of vertical distance, or sorry, diagonal distance will be your hypotenuse. So, we're trying to find how far does a chairlift travel. So, if it starts down here on the ground and travels up to the top of the mountain, are we finding the horizontal distance? Or like the diagonal distance. So we know that this is the opposite. We already said that out loud. What other side are we trying to find? Hypotenuse. So which trig function can we use? Sine. Yep. So sine of 20.75 equals our 1,200 over our hypotenuse, which you don't know. And then we solve for x. And we'll put x up here. So x times sine of 20.75 equals 1,200. We have to divide sine of 20.75. We have 1,200 divided by sine of 20.75. So it's 3,387.1 feet. Make it sound later. Alright, because I got 3,387.045. You could have done 0.04. That one, like I said, sometimes those are tricky to round, so I just went ahead. I said the 5 rounded up to 4 and the 4 rounded up to 0. So as long as you're close, you're fine. So that's what I did for that one. Any questions? The second one's a little bit trickier. There's actually 2 triangles that we are working with at the same time. So I'm going to get this drawn for you, and then we'll do this sightseeing question, and then we'll be done with our packet family. Alright, so a sightseer on vacation looks down at a deep canyon using binoculars. The angle of depression to the far bank of a river is 61 degrees, and the angle of to the near bank of the river, which I think I forgot to type the river, but that's what we're talking about. There's a river down in the canyon. So when he looks down to the far bank, it's 61 degrees, and then he has to turn his head just a little bit more to look at the closer bank of 63 degrees. If the canyon is, if he's 1,250 feet above that river, we're trying to figure out how wide the river is. Okay. So a lot of times I try to give you these pictures that are already kind of drawn out the situation. Essentially what we're looking at are 2 triangles at once, because we're looking at the angle formed when he looks down to the further bank of the river, and then we also have another little another triangle when he turns his head a little bit more and looks at the closer bank of the triangle. So this is how I'm going to draw it. Start with a better triangle. technically, where the angle of depression comes from is if he's standing up here on the top of the canyon, he's looking straight out and looks down at this river. So it's not this angle, it's actually this one out here. But like I said, whenever you're looking at angle of elevation or depression, really it's from the horizontal up to the person. So where I'm going to label my 61 is actually down here because I like it better down there than up here in space. Okay? So that's him looking down at the far bank of that river. Okay? Like I said, technically where the 61 would be, if we're talking specifically angle of depression, is out from here down. But like I said, I don't really want this angle up here in space, so I just label it down here on my triangle because, like I said, those are alternate interior angles, so those are the same angle that we have. Okay. I don't know where his other one went. So then he turns his head a little bit more and looks down at the closer bank. Okay. And again, where that angle would be is kind of out here in space. So where the 63 is going to go is my littler triangle here, right in that corner. So the river, hope it doesn't confuse the triangle if I'm trying to draw a little bit of the situation, is in between those two little triangles. And then he's standing 1,250 feet. Where would our 1,250 go?
It's going to be the opposite.
Yeah, right here. Okay. So there's the situation. Like I said, a lot of times when I give these problems to you, I already have this picture drawn, so you can kind of see it already. But whenever we're talking about really two triangles, it's going to look something kind of like this. And so then what we're trying to find is that width of the river. If you look at that, it's not really either side of this triangle, okay? Because it's just this portion of the triangle, and it's right before that one. I suppose I can find the width of that river. Yep. Solve the two triangles. We can find this total distance out to the far bank. We can find the distance to the smaller or the closer bank, and then if we subtract them, that'll give us the width of that river. Yep, so that's what we're gonna do. Everyone good with that? So, what trig function are we going to use to be able to find this distance and also the smaller distance? If we know this angle. Yep. So we're going to have to use TOA. Because no matter what, this is the opposite. And these are our adjacents. Okay? So, we're going to have to, like I said, we're going to have to solve it twice either way. So we're going to do tangent of 61 with the 1,250 over. I'm going to use a different letter because I've already labeled X. So I'm going to call this total distance here. We'll call that Y. Okay. So that'll give us that total distance from the edge of the canyon to the far bank of the river. So go ahead and solve that out. So I've multiplied Y and then divide the tangent. So the total distance from the edge of the canyon to the far bank is 692.9 feet. Okay. So that gives us that total distance. So now we're going to find the distance from the edge of the canyon to the closer bank of the river. So do tangent of 63 equals 1,250. And I'll call this distance Z. To get us that from the edge of the canyon to the closer bank of the river. So again, we have to divide. I'm not doing a good job of showing my work on this one. Is that okay? Everyone following? We've done enough of these that I think you know the order. So I take 1,250 and then I end up having to divide by tangent of 63. So that is 636.9 feet. So to get the width of the river, I need to take Y minus Z. Okay. So to get X, we'll take 692.9 minus 676.9. So it's 56. Makes sense. We've done questions like that before, so hopefully that seems familiar. Maybe not canyon and river, but like car and distance between a person and people from a building. So okay, so hopefully all that made sense. Like I said, we did a pretty extensive right triangle stuff last year, so hopefully that all seems a little bit familiar. So finally done with the notes. So we do have another worksheet though.